Okay. Okay, let's get started here. Okay, guys. So what we have done yesterday is we have seen, we have basically tried how to create an infrastructure using Terraform. We have talked about how to deal with locally. How to deal with the local file operations. Okay, and provisioning infra, which means we have created an EC2 with the Terraform. This is what we have done. And even also we have talked about the lot of keywords. Not like lot of keywords, the life cycle of the Terraform, the keywords that we have used. We have seen how to use a variable, how to use the output variable, how to use the data. This is what we have learned so far. Okay, the remaining thing is handling a state file. This is one thing. But before going with this, we want to discuss one more thing, which is an important, which we did not mention here, that is related to the modules, Terraform modules. Okay, even though we did not mention here, we have to talk about it. Let's talk about that here. Okay, so the point is, I have already opened a couple of things. Not this part. So this one. Okay, what we do is, first we will understand the how we will be using the modules. Then we will come to here, like we will go through or walk through some of the Terraform examples. How do we write it? How they are using it? Okay. Okay, here it is, the one. This is what I have found is very easy actually. Okay. Easy to understand based on what we have done. So basically, we are going to create a modules using a Terraform, which are going to be reusable, meaning if you know any of the coding language or either Java, Python, or C, anything, right? You will write a functions, right? What is the main purpose of functions? To reusable, meaning you just define a function in one way and then you can call it any times. Similarly, you would be creating a modules. The modules will have a main.tf file, variables.tf file, data.tf file, output.tf file. These are the files that we do have. The main thing is main.tf file should be present under your modules. For example, if you are creating a module, what you need to do is, for example, this is a folder, and inside a folder, you have created a module 1 here. Okay, so under the module 1, your folder structure should be contains a main.tf as a mandatory one. After main.tf, you can have a variables.tf, you can have output.tf, you can have a data.variables. So you can, these are optional, but main.tf will have an option. So once you have created this module structure like this, you need to refer this module in your another place. Okay, meaning you have defined a function now you have to call it, right? So this is nothing but you are calling your module, or you are utilizing your module in wherever you want. Okay, this is a example which I have shown, which I'm showing you right now. So this is very simple actually. Okay, so now let me walk through this. Okay, so what these guys are saying is, this is what they want to create a infrastructure with the auto scale enable. Okay, meaning there is a one RDS instance, there are one EC2 instance which enabled with auto scaling, and then attached this instance to elastic load balancer. This is the infrastructure they want to create it. Okay, so this is similarly they want to utilize for, they want to create two environments. One is a production environment, another one is a staging environment. But for both the environments, the work is same. So what they are going to do is, they are going to create a module for this entire thing, but they are using a different purposes. One is for creating a staging environment, another one is for creating a production environment. Okay, so now, so for example, they have some Python file that is an application part. We don't require to deal with that. Okay, see this here. So here, if you see, there are two environments we have to create it. For example, the task you got like, hey, Naveen, you need to create an environment, or you need to provision an environment for a prod and prod and staging environment. Prod instance or any, if you take any of the environment, it should contains one RDS, one EC2 with auto scale enable, one, and that EC2 should be attached to ELB. This is a problem statement or requirement as given to you by your lead or manager. Okay, so for that, what you need to do is, if you see here, they have created a two separate folders, stage and prod. Under the stage, they have a services and they have a data store. Okay, here also, if you see here, for the prod also, they have a services, they have a data stores here. Meaning, what is meant by a services? Services, basically, they are referring a one task. The task is nothing but a web server deployment or in the cluster mode. Cluster mode is nothing but a, here they are talking in this context, the cluster mode means attaching EC2 instance which enabled the auto scaling and attach that to ELB. So this is what they meant for the web server cluster here. Okay, now for the data stores, stores, they have written a one main.tf file how to launch a RDS instance. This is what they have been given here. Okay, similarly for the, they have done for the prod also here. They have a services, and the services they have given for the web server cluster, data stores, and all this now. And they have used the S3 for some other purpose, but they are kept in the global.s3. So this is how their folder structure they have been defined here. Okay, so as I mentioned here, first you have to create a folder called modules. Under the modules, you can directly create variables, outputs, main.tf, user data.sh. sh means it is optional. But why they have written a .sh? I mean, the shell script is, while launching a web server, they have automated something that they have written in a shell script. They will be executing the shell script in any way, somewhere in the main.tf. This is what they are doing it. See, the first thing is you have to create a folder called modules. Under the modules, you have to create a your service name. Under the service name, you can directly create another subfolder, or you can create a variables.tf also. That's it. Nothing as much as possible. Okay. Next one is similarly. Now let's see how they are utilizing these modules under the stages here. Okay. Now what I'll do is I'll open. I hope you guys can see my. I think let me stop it here. Okay, so now I am opening this one. So what I'll do is I'm gonna create like what I'll do is new window, and then I'm closing this one here. What I'll do is I don't have any folder, so let me create it here. Infra provisioning. Okay, this is what we have created. Let's use this folder under the desktop. Same much, and this is the folder which I'm gonna do it now. Okay, so here I'm gonna create. I'm just following this guide, so this would be helpful you for all this stuff here. Okay, now let me create a modules. Under the modules, I'm gonna create another one that is nothing but a services. Under the services, I'm going to have a web server hyphen cluster folder. Okay, this is my module structure. Okay, under this, I'm going to have a main.tf. Under this, I'm going to have a variables.tf. Under this, user data.sh. And what else they have? Variables.tf, outputs.tf. Okay, this is their folder structure. This is how they have to create. Under the modules, I do have a one service. That service name is a web server cluster. Okay. Now let's see what they are doing here. Okay. After the modules, we should have another folder called stage. For example, we are providing we are provisioning the staging environment. For this, under this infrastructure provisioning, I'm going to create a note here. Under the modules, not modules, not modules. Basically, we should have a okay, let me do one thing. Let me create itself stage. Okay. Now we do have all this stuff. Okay. Now similarly, we are going to have a okay, not this prod environment also. Okay, these are the now we have a module called services. Under the services, we do have a cluster. Now let's go here. Under the services folder, we need to create a web server cluster and then see how we are going to do this. Okay. Under the services, why did they let's go this and then find here. Data stores. But the data stores, you are going to have a MySQL. Under the MySQL, you are going to have a same main.tf, variables.tf, output.tf. Okay, so these are the modules definition. I do have two modules, data stores related and services related. For example, if I want to if I want to have another services, what I can do is I can create a MongoDB related MongoDB, and under the MongoDB related, I'll have a main.tf output.tf for now. Okay, so currently I'm going to in this main.tf, if you ask me what we will write here, right? So basically two things here, resource, and resource type is MongoDB, and this is a logical name, AWS Mongo install. Okay, before doing this, and obviously the properties, and you should have a provider. The provider should be Mongo. See here, I think AWS Mongo install. No, it should be Mongo only. So you should have a version and everything. So version, I don't know anything. So I'm just telling you what it contains, this main.tf file under the modules. So you will, as usual, what we have learned is we should be defining a provider, we should be defining a resource, and as well as its properties. Similarly, we'll have a MySQL related also. We know how to use their providers. Okay. Now, similarly, now let's come to the web services. Web server folder. This is where provider of AWS and 3.17.0. For example, I'm just giving the rough block here. Instance and EC2 prod. Okay, and its properties. Now, what we have done is we basically created a modules related to the data stores, which is related to all the databases, and related to the service currently web server cluster. For example, if I want, now let me do one thing here, Kafka related, which is a message processor, Kafka processor. Okay, now under the services I have written two submodules, Kafka processes and web server cluster, which is nothing but installing. Under the data stores module, I have module related to MongoDB and MySQL. Now let's see how we will utilize under the prod environment and stage environment. Okay, now we have defined our own modules. Now let's see how to use that in first. Okay, now let's create a main.tf here. And under the main.tf, if we go here, see how we will be writing this code here. So module name, source, and everything. So we have to import a module. Module name is services, and source is, currently this is under, right? This is the source part. Dot. Yes, it is. This is one which I want. So this is how I import a modules. Okay. This is how I'll import a module. Once I have utilized the module, once you have utilized, similarly in the prod environment also, create a main.tf and define a module, import a module. Module is, for example, in this one, services, source. I'm going to create a same thing here. Okay. Now I have written everything for the prod and staging environment. Now, next thing is, first thing is, anyway, either you can define this provider in the main.tf of any of the environment, or since you have defined here under the services web server cluster, right? Since you have defined here, it is also fine. It's up to you whether you can define in the main.tf of the prod environment or stage environment, wherever you are importing it. Okay, this guy is using in the main.tf. Once he has done it, he is directly initializing it and then utilizing it. So automatically that particular module will be initialized. That's it. Nothing, you don't need to worry about it. This is what, in this example, what this guy has done is he's just executed a simple Python related command. That's it. So this is how they have defined, or this is how they have to use a modules. See here, for the web server cluster module, you have to import the source code where it is, and then that is currently taking a three parameters: cluster name, DB remote state bucket, DB remote state key, and everything. So these are the three parameters which you have been defined in the module. So there are two things we have learned: how to create a module now, how to import that, how to load, and then how to use the module. If your module required any of the parameters, you have to define. For example, if you want to know the For example, we have imported the web server cluster, right? Let's see here. Under here, for example, we have defined data, a variable name is myvar, and here cluster name. Okay, so and for example, in the AWS instance, there is a name property called here, right? Here you would be using myvar. This is meaning in the resource while while creating a AWS EC2 instance, there is a key called name property. They are passing a dynamically the value of this parameter. How they are doing? They are referring this one. How this variable is getting a value? Because of while you are importing a module, here you have to provide a cluster name. And then cluster name is my web server cluster. This is how you need to pass a argument to your module. I hope it's clear. Okay, this is what I want you to discuss it with the modules now. Okay, now what we'll do is let's understand some of the open source related projects and then see how they are doing and then how they are utilizing it also here. I hope you understand the concept here. Okay, of course we did not do a dry run because we do not have a source code out of it. Now we will go and see that Terraform example. So I have already opened a couple of things here. What I'll do is Terraform GitHub examples. Okay, container solution. He has written a Terraform scripts related to the containers. Let's open and see what they are doing. Okay. Let's go and see how we need to run also here. You can go through the README. If you don't understand, you can directly go to the AWS example because this is where we want to understand how they have been written here. Okay. For example, they are creating they are creating a project here. Similarly, we have an infra provisioning, right? Let's similarly create another thing called what they have something like this. AWS, what is that? AWS DB instance. So like we have created this folder, right? Similarly, where is this? Okay, you can create also folder or your project name like this. Under this, let's see what they have written. See, they have a sub modules also here. Postgres, a restore, and simple. I think, yeah, what they are doing is they are utilizing the variables directly here. So I think if I tell you this, you will be confused. Now let me do one thing. Let me pick up another source code, which is very easy. What this guy is doing. Let's see this Lambda API EC2 basic Docker host. Okay, fine. Let's take this as an example because it is very easy. What this guy is doing is he has created a folder called AWS EC2 EBS Docker host, meaning he is creating one EBS volume and then attaching to that EC2 machine. That is the main functionality of this guy. Now, similarly, you can also create your project with the same name. For example, if you want to create a VPC and then attach that to a couple of EC2 missions, you can also create a a folder similarly with the name of the same project. Okay. AWS VPC configure. Okay, that's it. Okay, right. Now AWS VPC configure. Once you have done, let's see how their folder structure or how they are organizing. As usual, they should have a main.tf. Okay, because this is an important part. Main.tf. Let's see what they are doing in the main.tf. In the main.tf, they are declared, they are using a couple of resources. The resource is AWS instance. And if you see all the properties, they are passing as a variables. How they are getting a variables? If you see here, $_var.instance type, right? If we want to see what is the value of this instance type, there is a file called variables.tf. See here, under the variables, instance type, host name, instance AMI, they have defined here. Instance type is T2 micro, instance AMI is this one, instance private key path is private key, I mean SSH.private key, and SSH username is Ubuntu, VPC ID is nothing. So they have defined all the variables in one of the file called variable.tf. Now let's see how they are utilizing. This is how. This is how you need to define, or you have to write a Terraform script how to call a variable from a variables.tf file. You have to just define a dollar of curly braces. Now let me put it in the notepad. Easily you can understand. Dollar curly braces var dot that variable name. Okay, that variable. The example could be dollar of var dot instance type. This is my variable name. This is how I'll be defining here. Okay. Now, similarly, if you see here, all they have defined all the variables from the variable.tf file. If you see here, data.aws subnet.this.id here. Now, what does it mean here is that there is something called data.tf. So if you want to define any static or dynamic values, you have to create a file called data.tf, and then you have to define that data type name, which is a custom data type, meaning correctly he's telling to Terraform, hey, I'm going to create a data structure which is a type of AWS availability zones, AWS VPC, AWS subnet. Okay, this is how they are been referring it. If you see here in the data also, they are calling the similar way, var.vpc id. Okay, this is how they have been referring their data variables in the main.tf. Okay, now we have seen, I mean, we already know about it. Okay, these are the merge, I mean, these are some of the confusion things, which is basically a function, predefined function in the Terraform, which will merge the tags and host names. This is an inbuilt function. Like if you know the Java or Python, there are some functions, right? Inbuilt functions like a substring, dot length, string dot length. Similarly, there is something called merge. This is a predefined function. What does it doing is it is mapping the tags and host names. That's it, nothing else. Then this AWS instance required these parameters. Along with that, a root block volume. He is also defined all the things also here. And next one is inside this resource itself, he is using another provision called remote exec. If you remember yesterday, we have tried the local file, which is a provisioner, okay, which is a provider. That provider will help you to create a local files or manipulate the local files. Similarly, there is a provisioner called remote exec. What does it do is it will just execute whatever the commands that you have given in the remote mission itself. In this context, whenever this is going to create a EC2 mission, it is going to execute these commands inside the EC2 mission. Similarly, he is executing the a shell script also. Similarly, he is creating a file after executing the shell script. Similarly, he is using the same provider. He is doing a removing and then doing a couple of files copy. So for all these, he has used a remote exec because he want to execute all these functionalities inside a remote machine. Okay, so this is how he has used another volume attach and then null resource. There is a bigger concept for the null resources. We won't use it as much as possible, because that will make your work very clumsy here. So don't go with that. Of course, what they are doing is, when do we, I mean, I'll give you the context here. Null resource is a type of a resource which will be accessible for every type of provisioner. For example, AWS or Azure or GCP or any of the things. What does it do is, when you don't know what is the output you are going to get it, right? You are going to just display this null resources. That's what, nothing else apart from that. Okay, I hope this may confuse you, but just to have a thought about it. There is a null resource. If you are attending an interview, they might ask you a question also, what is a null resource also here. Okay, so this is how they have defined their main.tf. And remaining as usual, variables.tf we have seen, data.tf seen, in the output.tf file, right? See, this is what they have defined. Whenever they executed the Terraform script, if they want to display all the outputs, like what is the host name, what is the public IP, what is the instance ID, what is the availability zone, what is SSH username, private key, security group, if you want to display those, right, after executing Terraform apply, you will also apply Terraform output. Or else, when you do Terraform apply, it will auto display the output also here. It's nothing else on top of this. Okay, so that's what this outputs.tf. And remaining files, if you see here, all the SSH, right, SH files, which you might have seen, they would have used somewhere else here. See, provision.sh, provision.swap, provision, they are replacing it. So these are the files they have been used. And similarly, as we know, main.tf, we know, outputs.tf, variables.tf, and data.tf. Now let's see the security.tf. This we have seen here. I mean, it's nothing like, you can create narendra.tf, but you have to refer somewhere with the same name. So what, for the meaningful decision, what they have done is, for all the security related configuration, they have created a file called security.tf. Inside a security.tf, they have defined how they are generating the public and private key along with the security groups, its rules and everything they have defined here. See here, they are creating a rule for 2022 port, 80 port, 53 port, and 53 port for input and output. Okay, this is what the security groups they have written. So I hope you understand what I'm talking here. Okay, so simply thing is, you just need to clone this project and then try to see it what is happening. If you want to run this project, there are a lot of things you have to follow for this example. First, you have to define your module, you have to define your host name, public key, private key you have defined, and everything you have to do it. So what they are doing is, they are just running a Docker inside of it. Okay, see, you have to follow everything. You have to define all these parameters and everything. If you have a time, you please go ahead, but this is a good start if you want to start any of the project also. So what this is doing is, it is attaching a one EBS volume to EC2 instance via Docker. So that is what it has been doing. Any questions, guys? Okay, if not, let's move ahead and then see the similar stuff. If you take any of the AWS related stuff here, right, what you can do is, if you see AWS Lambda API. So they have a main.tf, data.tf, outputs.tf, variables.tf, and remaining all files related to API gateway or for their own requirement they have given. For example, if you want to create a Okay, thank you, Naveen. If you want to create any project, similarly, for example, they might give you a project called what do you say? AWS EC2 RDS Kafka. So they want to create an infrastructure in AWS. It has to install, I mean, it has to provision EC2 1, RDS1, and Kafka server. Okay. So once you have done it here, similarly, you just need to create a file called main.tf, which contains all your basic logic. And similarly, as you know, okay, not a folder. I'm gonna delete this. I'm gonna create a file again, variables.tf. Similarly, I'm gonna create okay, what is happening? Okay, so what I'm gonna do is I'm going to create a renaming of it. So instead of creating all this stuff, right? Outputs.tf. I do have a data.tf. Data.tf. Since I want all the related Kafka manager, right? What I'm gonna do is I'm gonna create a Kafka config.tf. So this way, all my Kafka configuration, all the configuration related data, I'll be defining under this variable. Okay. Now, similarly, I want EC2 and as well as the RDS. All the, sorry, it should be .tf. So you have to define, I mean, I have defined all the variables related to the EC2 and RDS in the similar file. So I can refer in the main.tf file. So this is what exactly they have done it here. Okay. If they want to configure something related to, especially for that particular resources, they will need to create a separate thing like this. AWS EC2RDS.tf I have created, right? Similarly, here also they have been created here. That's it. Okay. That's it, guys. Mainly, whatever I want to suggest you is go through this one because this has a basic code, which means you can just, you don't need to try in the first phase. Just go through this source code and then try to understand what this, why this data, each and every line you can read and then try to understand where it is been referring also. Okay. So yeah, this is it for today. Tomorrow we are going to discuss about the Terraform state file handling. So there are a couple of interview questions we need to be handled. I mean, we need to get, we need to know also related to the Terraform state file. We'll discuss it tomorrow. That is only like a 20 minutes of concept. It is all theoretical part, and then the practical part is we need to open one of the TF state file and then understand it. That is one thing. Okay. It is a 20 minutes class, and remaining things we will be starting the Ansible. Okay. This is what we'll be planning for tomorrow. Tomorrow 7 a.m. Unfortunately, I do have a fever and a cold cough yesterday, so I couldn't able to make it morning. So that's why it postponed. But as much as possible, I'll be having a morning class tomorrow, which is a 7:30 a.m. as usual. Okay, right? Thank you, guys. You can just go through this once and then try to understand. Naveen, are you there? Sorry. Any questions? Hey, Sharanya. Welcome back again. Okay, right. Uh, Sandeep, are you there? You can stop recording. Okay.